So there's several big changes that we're making from Phoenix, our 2014 rover. One of which is that we're angling the suspension A-arms such that we can attack higher grade slopes at faster speeds. One of the mechanical team leads has actually designed custom dampeners, and it's been a really neat process to watch him develop them because he's actually used the appropriate spring rates to give us the right ride height as well as the full compressive stroke that we want. We're utilizing a lot more composites this year, which has really given our team a good opportunity to grow in that area. Another really big important change that we're making is our carbon fiber wheels. With the carbon construction, we're going to be able to more effectively create paddles on the wheels that will give us more force to travel up granular inclines. There's been weight reduction pretty much across the entire rover. The frame itself has lost a pound. We're estimating to lose 15 pounds from the new wheels. Our propulsion system is going to be utilizing brushless motors, which are going to give us more power with less weight. On this year's rover, we've made a big point to use more high-efficient materials like aluminum and composites. There's many ideas and concepts that have been developed through rover that are going to have a much greater significance outside of competition, and that's kind of what it means to be part of Missouri S&T rover team, is that yeah, we're doing a competition, but we're really trying to innovate and come up with new ideas and easier ways to build things and more creative ways to utilize current materials.
This year we have a heavier focus on science. The competition guidelines state that we need to test for soil pH and soil humidity, and we thought that would be a little too easy. We didn't want to just make that goal and be done with the competition, so we started designing experiments that were going to go above and beyond and not only push the competition farther, but push ourselves farther. We are currently testing the pH sensors in soil, and we're doing really well with that. Our other experiments, there's a Raman spectrometer to search for biological markers in the soil. We're also doing a dual heat probe pulse for specific conductivity, and that's also going to look for the biological life. Currently, we are finishing up our 3D optics holder. We have all our diffraction gratings and mirrors in, and once this is done, we'll have a final prototype.
On the motherboard side of things, we switched up our processor. We stuck with the TI Launchpad. The only difference is we found a Launchpad that would have an integrated Ethernet stack to it, so we were able to use that instead of an off-board chip. It allows us to pull the data off faster and better. We're pretty confident in that design, and we have tested the board and it works for right now. It has all of its connections working, and we are able to switch between all of our communication. A big change that we had in telemetry controls is we switched up the robotic arm. A big thing that we tried to do this year is we're going to use the Dynamixel servos to help the control scheme a little bit more. They're easier motors to handle and send packets and create closed loops with. So we're going to get more precise data back from them so that we can make more precise movements with the robotic arm. The other thing that we decided to do is we decided to switch up our motors to be brushless motors. So they are brushless AC motors, and we got off-the-shelf motor controllers, so we feel very confident in our hardware side of things, and we feel very confident in our ability to create, once again, a control scheme that will allow us for more precision when driving and better torque on the ground and other things like that. So on a power electronics side of things, we have beefed everything up. So last year we had a lot of issues with not having heavy enough copper on all of our boards, and small traces were almost evaporated by the amount of current that we were putting through it. So all of our power intensive boards, the two main ones are the power board and the solid state relay board. Both of those boards were printed on 2-ounce copper, a thicker copper that will allow us to push more current through. On the power electronics side of things, we are currently in the testing phase, and what we're doing for testing is we're load testing all of the outputs for all the buses on the power board, as well as pushing enough current through the SSR board, and we're monitoring all of those tests with a thermal infrared camera. It'll allow us to see the heat signatures and any fail points or potential fail points. We feel very confident in that testing, and that the more tests that we can create on these boards, the more realistic it will be when it's in the rover. So we're going to extensively test it over the next few weeks to make sure that we're solid, and then move it into the rover integrated in.